I'm Jonathan Rosand. I'm a professor of neurology at Harvard Medical School, and I'm a doctor at Mass General Hospital. So our lab and our collaborators from around the world, including here in Hong Kong, are all working hard to find the genetic variants that not only give rise to stroke, but also influence how well we recover when we have a stroke, because those variants will point to what's going on inside us when strokes occur and highlight new drug targets. Genome-wide association studies are this marvelous innovation that have developed over the last now roughly 10 years. And what they allow us to do is ask whether any variant across the entire genome that we inherit from our parents might have a role in influencing a person's risk of having a stroke or a person's ability to recover from stroke. To understand how genetics has an impact on whether or not we develop a disease, but how tall you are, what color our eyes are, you want to think about our genes as an instruction manual. And each of us has the same, if the instruction manual is, let's say, 15 pages and several paragraphs on the page, the general content of the paragraphs the same between all of us, among all of us, no matter whether you come from Africa or Asia or Europe. But there are small differences, and those differences will be, for example, in a word in a paragraph, or in a letter in a word. It might be a misspelling. So to find these small differences, you need large numbers of people. There are so many different places in the genome that influence your risk of stroke, and they influence the risk of one type of stroke or another, or they can influence the risk of all strokes. But in addition, we learned that the same regions of the genome that influence risk of stroke, they influence risks of other diseases. So that helps us to understand how these, the biological processes that lead to a disease might overlap between stroke, let's say, and heart attack, or stroke and high lipids, or stroke and diabetes. The first thing you see is how difficult it is to reverse the disease once it's there. So prevention is the obvious way to go. Is basically what was done for heart disease. And it was such an obvious approach, but you couldn't do it until recently because we didn't know enough about brain disease. We didn't know enough about stroke or Parkinson's or depression. But over the last 10 years, there's been a revolution in neuroscience. And we have a much better understanding of the molecular pathways involved in these diseases and how to capture on imaging the impact of these diseases on the brain. So there's enough knowledge now to start really looking at how to prevent these diseases. Think about a future where today, if your blood pressure is very high in the office, your doctor doesn't wait for you to have a heart attack, doesn't wait for you to have a stroke. Your doctor gives you a blood pressure medicine to bring the blood pressure down. Your risk of a heart attack or stroke plummets. Think of the day when the same thing happens for Alzheimer's disease. That's our goal for brain health. When you learn that your risk for disease is higher than you expected, that's, in our experience, an opportunity. It's an opportunity to intervene. It's an opportunity to make a change. It's frightening for all of us, but when we're frightened is when we're most motivated. And these lifestyle changes, these lifestyle habits, they're hard. So if you learn that you are suddenly at higher risk than you thought, this is an opportunity to go seek help and to make the changes that you can probably make to reduce your risk substantially. Well, we are actively studying now stroke recovery and its genetics. There's some very exciting research from colleagues within the International Stroke Genetics Consortium that has highlighted a couple of new biological pathways. I'm optimistic that in the next 5 years, you'll see a whole set of new drug targets that are going to be explored by university and pharma investigators. So stay tuned.